Hi, I'm James Reichenbach, and this is my Chi-Square project for my statistics class. This is my introduction of the topic. For my project, I chose to look at the relationship between gender and the choice of dinner beverages when when they're eating. This is part two of my statistics project, which consists of my hypothesis. Here we have the null hypothesis, in which gender and dinner beverages are independent. And here's the opposite, in which the gender and dinner beverages are dependent. This is part three of my statistics project, where I show the copy of my survey. This is what it looks like. I have the question at the top: what do you drink at dinner, male or female? And then along those lines, I have milk, water, and other. Other could be soda or tea or whatever else they wanted to drink. I told that to the students who were taking the survey, and as you can see here, this person was male and he drank milk. And I went through 50 other students during their classes. This person was male and drank water. And once I filled out all of the surveys, I collected my data and started my project. This is part four of the Chi-Square project, where I created an observed table from all the data that I got from these 50 strips. I have a male row and a female row, totals at the bottom for the columns, and totals on the side for the rows. I had 12 males who drank milk, 8 males who drank water, and 4 who drank something other than milk and water. For the female row, I had 2 that drank milk, 20 that drank water, and 4 who did not drink milk or water. The totals for the males was 24 and 26 for females. We had 14 total people who drank milk, 28 who drank water, and 8 who drank something other than milk or water. Part 5 of the Chi-Square project was to then create a expected table from the data that we got from our observed. And to do that, you have to take the total from the column times the total from the row divided by the total number of students that were surveyed, which is 50. And you do that for each and every box, and you get your numbers. So for the milk, we had 14 total who drank milk and 24 males. Divided by a total of 50 people, you get 6.72. Same sort of deal for the females. You have 14 total who drank milk, and there were 26 total females. Divided by 50, which is the total number of people that were surveyed, you get 7.28. All this data will play in part for later steps. Part 6 in the Chi-Square project is calculating test statistics, and it is found by taking the observed minus the expected and squaring that all over your expected value. So what that means is, for every box, you have to take your observed minus your expected, squaring that, and then dividing that by your expected. So for the first box, we did the male milk, and we have 12 males who drank milk at dinner minus our expected, which was 6.72 that we got from the table over there. We square that and we divide it by our 6.72 once again, and then you get an answer like that, which equals 4.15. And you do that for each and every box. So for this one, we took our males who drank water, that was 8, and our expected down here, that was 13.44. You take your observed minus your expected, squaring it and dividing it by your expected, and then you get an answer like 2.20. You do that for each box, and you add all of these values up, and that gives you our calculated test statistic,
Part 7 of the chi-square project is to determine the critical value from the chi-square table, which we have in front of us. We always use the 0.05 scale, and we have to find our degree of freedom to know where we have to go across to meet up with the 0.05. So to find our degree of freedom, we have to take our number of rows, which we have 2, our male and our female. We have to take the number of rows minus 1 and the number of columns minus 1 and multiply those two values together, and we get 2. So 2 is our degree of freedom, and we come along here onto this chart and we find 2.